So this problem covers, actually I'm going to show you a few problems that cover inverse functions and their derivatives. So this is the first example. They give you this function and they want you to find the derivative of this function at the derivative of inverse of this function at 3. Well, you have to memorize this formula that we talked about it a lot. We derived it a few times. Oh, I can remind you how you derive it, but you do need to remember it. So if G and G inverse are inverses of each other, then this is supposed to work. That we learned in Algebra 2. So now if you differentiate both sides, you'll get G prime of G inverse times chain rule, so you do G inverse prime equals 1. Therefore, this part, the inverse, G inverse at a certain point equals to 1 over G prime of G inverse at that same point. So unfortunately you do need to memorize this formula, otherwise it's going to be hard and you're going to lose so much time trying to figure out these kind of problems. So what I would do to make it easier for myself, so we're looking for a G inverse at 3, first of all. That's what we're talking about. Then we need to find the derivative. So I'm considering two functions, G and G inverse, right? And we're talking about point x equals 3, but we don't know what the y value. So let's call it, I'm going to use different color. Let's call it k. And then since they are inverses of each other, and you remember how domain becomes range, range becomes domain, so then k represents the x value for function g, and the y value would be 3, right? Now if you look at your main formula, in order to find g inverse of x, I'm sorry, right here it's supposed to be inverse. You need to divide 1 by G prime of G inverse of 3. So in other words, you need to know what G inverse of 3 is first. If you determine that, then you can do the rest. So G inverse at 3 in this case equals to k. We don't know, but we do know that G of k equals to 3. So if we replace this part right here with 3, which is the y value, we can always find the k value, which is the x. And that we can plug it into this function. So when x equals to 3, k equals to whatever we get. So here's my first step. So I'm going to replace g of x with 3. 3 equals, and then put x to the 5th plus 3x plus 2. Now I'm going to solve it for x. So in other words, I'm looking for this k, right? That's easy to solve. Plus 3x equals, the 3 minus 2 is a 1. By the way, you're allowed to use your calculator on this particular problem. That's what it says. So if you graph this quickly and find the x value, at this point you need to trust me, you get x equals 0.332. You're allowed to round to the nearest thousandths. So we found our k. So here it is. That's our k. So that means G inverse of 3 is 0.332. Alright, now we're going to go back to this formula, and I'll use a different page. So G prime of x, or you can say, G inverse of x prime, or you can say I'm going to use different color. G inverse of 3 prime equals, and we said that's 1 over, and you put the regular function first, G prime, and then of G inverse of 3. If you go back and check that formula, that's what you'll see. Now, we already found this, the G prime of 3 right here. G inverse of 3 equals to 0.332. So this is 0.332. Therefore, you get 1 over G prime of 0.332. All you have to do now is just find the derivative of G, the original function, and replace x with 0.332, and just finish your problem. You're allowed to use your calculator, so what I would do, I would just graph G prime, take the original function, but graph its derivative, and then evaluate when x equals, the routine, the second trace value, calculate value, and then just enter 0.332, and that gives you the answer, whatever it is. I believe it's 1 over 3.61, and then finish it and you get 0.327. This is complicated because we have a bunch of decimals. Usually they give you these kind of questions, they give you on multiple choice where you're not allowed to use your calculator, so which is much easier. So I would like to show you a couple of more examples.